Today, our group will be exploring the concept of projectile motion and some of the maths that surrounds its many interesting applications. Projectile motion is just that, the motion or path in which a projectile follows given certain forces acting upon the system. The path or motion that the projectile takes is a curve, and when applied to a graph, we can see and find out some interesting characteristics of different systems based on the way the curve looks and behaves. We use projectile motion in our everyday life more than most would care to admit or know. There are many sports that require our brain to take into account the curve of a ball through the air in order to either hit it or block it. It depends on whatever sport you're playing. But projectile motion is more than just sports as well. It has a lot to do with the age-old saying, what goes up must come down. This means that any system with a force acting upon it in a horizontal plane and a vertical plane will eventually lose momentum due to gravity, and the system will fall back to Earth. There are many equations that can predict the curve of a projectile, so as to either predict where the system will fall or to understand the characteristics of the curve. I now leave you in the capable hands of Bobby, who will go into detail surrounding the distance between points and the intercepts of the curve, and explore techniques used to determine both.
Today in this video, I'm gonna show you how to find the distance between 2 points, midpoint between 2 points, intercept, and turning point. So let's start with the distance. From the picture above, you can see the formula of the distance, and I'm gonna show you how to use it to solve the question. Let's look at the example. The example says find the distance between 2 points, and our x1 is 1, x2 is 2, y1 is 2, y2 is 3. So we just substitute our x1 and 2, y1 and 2's into our formula and we get our answer. For this example, distance between those points is 2 under root. Let's move on to the midpoint. From the picture you can see the formula for midpoint for x and y, and I'm gonna show you again how to use it, and I'll use it on this same example. So we just substitute our x's and y's into our formula and we get the answer. For this example, midpoint locates at 3/2, its x coordinate, and y coordinate is 5/2. Let's move on to the intercept. Intercept is the point where graph crosses the x-axis and y-axis. From the graph, you can see that graph crosses x-axis at the -3 and 1, and it crosses y-axis at 2. So it means x-axis are -3 and 1, and y-axis is 2. To find an x-intercept, you need to solve that equation equaling it to 0. For this example, I used the quadratic formula to find my two x's. So for this example, my x1 is -1 plus 7 under root, and x2 is -1 minus 7 under root. To find an y-intercept, we need to substitute x zeros instead of our x's. So if we substitute our zeros into x's for this example, we will get -6. It means y-intercept is -6 and x-intercepts are -1 plus and minus 7 under root. And you have to remember that if the discriminant is less than 0, it means there is no real root. If the discriminant is equal to 0, it means only one root, and if the discriminant is bigger than 0, it means two roots. Now I'm going to show you an easy way how to find the turning point of the graph. Turning point of the graph is the point where graph changes its direction. So if you look at the picture, you can see the formula of turning easy formula of turning point for x and y's. Formula for x is negative b over 2a, and for y is negative b squared over 4a plus c. So let's look at the example. The example says find the turning point of this graph. So if you look at the equation, we can see that our a is 1, b is 2, and c is negative 6. So we just substitute those a, b, c into our formula and we get our turning point, the coordinates of our turning points. For this example, the turning point locates at x coordinate is negative 1 and y coordinate is 2. Thank you very much.
In today's video, I'm going to introduce how to move in graphs in projectile motion. For instance, in the equation of y equal to 4 times x squared, to move in the graph from the left to right in 1 unit, we do not have to recalculate and redraw the graph. We simply move the graphs 1 by unit and rewrite the equation by y equal to 4 times x minus 1 squared. And also, if I want to move in the graphs by moving up in 2 units, I only need to add as 1 equal to 4 times x minus 1 squared plus 2. And then, if moving the graph by moving down by 2 units, we simply need to rewrite the equation of the y equal to 4 times x minus 1 squared to y equal to 4 times x minus 1 squared minus 2. It is opposite when trying to move in the graph to the top. And then, if I want to move in the graph from the left to right, like to move in from the original point y equal to 4 times x squared, to move into the left in 2 units, it will be equal to y equal to 4 times x plus 2 squared. And then also, to move in down by 2 units, it will be y equal to 4 times x plus 2 squared minus 2. So here we can draw a little conclusion. If we set the equation is equal to y equal to a times x minus h squared plus k, so in order to move top, the k will be positive, and if I move to the left, the h will be negative, and also on the opposite side, the k will be negative. If it's moving down and the h will be positive, it is moving to right. And also, the h and the k is not the only factors that will determine where the graph moves. The a is also an important matter. For instance, if the a is smaller than 0, the graph will be facing down. And also, on the left side of the axis of symmetry, the y becomes larger when x is larger. And on the right side of symmetry, the y becomes smaller when x is larger. And also, when x is equal to h, the maximum is k. And also, when a is greater than 0, the graph will be facing up. And to the completely opposite situation, to a is smaller than 0, on the left side of the axis of symmetry, the y becomes smaller when x is larger. On the right side of the symmetry, the y is larger when x is larger. And also, when x is equal to h, the minimum is k. And thank you very much.
As introduced by Giles, projectiles are objects that when launched usually into the air by an external force have only one force acting on them, which is gravity. The motion of a projectile can be broken down into 2 separate motions. The first is the vertical motion, which is acted upon by the acceleration due to gravity. The second is the horizontal motion, which unlike vertical motion is not acted upon by the acceleration due to gravity. Whenever a moving object changes its velocity, we use the equation where a is equal to acceleration, v equals to final velocity, u equals to initial velocity, and t for the time taken for the object to complete its trajectory. Whatever goes up must come down. Vertical motion occurs when an object travels up and down. The object is thrown up using force and momentarily halts when the force due to gravity becomes positive, then falls back down. As soon as the object is thrown up, it begins to slow down until it stops and starts to fall. While falling, it picks up speed. From the previous equation, we take acceleration equations and change them to vertical motion equations, getting where a equals to ay, v equals to vy, u equals to uy, r equals to delta y, and delta y equals to the change of position of the y-axis, and where y equals to the y-axis. For horizontal motion, it only occurs when an object travels back or forth. The object is thrown or pushed in one direction and travels in that direction until stopped by external forces. From the previous equations, we take acceleration equations and change them to horizontal motion equations, getting where a equals to ax, v equals to vx, and r equals to delta x. Delta x equals to the change of position of the y-axis. Ux equals to the horizontal velocity of a projectile, and x equals to the x-axis. The vertical or horizontal velocity of a projectile can be calculated using simple trigonometry as seen below. To conclude, objects don't accelerate horizontally, but they decelerate vertically. Projectile motion is in action every time an object is thrown, dropped, or ejected. To solve projectile motion problems, you need to relate the motion's horizontal component to its vertical component. Most times, the time will relate the components together because the object moves horizontally only as long as it moves vertically.